Hey everyone, welcome to this webinar, Eyer for Eyer, how we at Eyer use our own AI observability for our own needs. My name is Ivar. I'll introduce the admins or the presenters in a minute. Be aware that this webinar is being recorded. It's going to be made available to signups a little bit later. We typically talk about Boomi in these webinars. So those of you that's interested in Boomi, you might want to check out the recorded webinar we held a couple of weeks ago, which covers Boomi specifically. It's on our webpage, but also on our LinkedIn events page. Please ask questions during this webinar, and I might pick them up and introduce them to the presenters during the webinar. And I think with that, let me add the presenters to the stage. Hey, Alessandra, let's get back to the presentation.
Hello, everyone.
Let's add Tigran. There we go.
Hello, everyone.
So Tigran, you're heading up development frames. Alessandra, you're heading up data science. I'm gonna let you take this from here, and I suppose Tigran, you're gonna take us through the agenda first.
Yeah. Hello, everyone. So today we're gonna look into how Eyer is operating, the algorithms, brief overview of our pipeline, and also dive into use cases. Why are we monitoring? And then we're gonna take a case study of monitoring the ML pipelines, and then we're gonna share some examples set up for specifically monitoring the ML pipelines. In this case, our own ML pipeline. So basically, Eyer is a cloud service, which means we have our strict SLAs that are contractually obligated to clients. And this means that we need to enforce those SLAs and make sure that the system is running all the time. And we're monitoring solutions, so it's very important for us that we don't lose data, that we don't stumble, and etc. And the only way to implement that is actually monitoring our own solution, automating actions to take upon some abnormal situations, and also this will allow us collecting the logs and basically making sure that we're meeting every SLA that we're promising. So for monitoring, we're using our own solution, and one of the biggest challenges we're solving is the setup and maintenance complexity. Usually what's happening is people are setting up some on-prem monitoring solution or cloud solution that requires a lot of configuration. You start configuring the thing, and I've seen it in a lot of companies before this. We kind of abandoned it halfway because there's always something more important to be done. Or even if you finish it in 2 months, there's a new release, new services are coming up, services are changing behavior, and nobody cares to go into the monitoring and fix everything. Or you just don't have time. Developers are always busy if you're running DevOps. And in the end of the day, you're ending up with monitoring that doesn't reflect your setup. And that's the worst thing that can happen because things are happening and you don't know why. Yeah, there's no data on that. What Eyer is actually doing, we're auto-adjusting to the changes in the setup, and we're adjusting to new behavior, onboarding new components automatically, so you don't have to do anything, basically. The monitoring is continuous, and it's aligned with the environment that we're monitoring. We're focusing on early notifications. So whenever something is about to go wrong, we're going to notify, and we're going to notify what exactly is happening, and also what components are impacted and how it's spreading through the system. And this allows to step in early and either prevent incidents, or in worst case, if incidents are happening, the incident response time is dramatically decreased because you have all the information in hand. You're not sitting in an incident war room and then wondering what's happening. Yeah, everything is just in front of you. We are using our own monitoring to extract some very important business metrics that actually are translated into some business KPIs, and that's basically proof on how good we're doing or how we're doing on the business side. And we're also using the monitoring for cost optimizations. I've seen it in a lot of companies that I worked before when people are having much bigger infrastructure than they actually require. Like, a huge virtual machines, a lot of web applications where actually, if you put some data behind that, you just say that 10% of the scale will be good enough for this, or might be good enough for this. So while monitoring you, we allow to do the cost optimization. You actually see how much of the system we're utilizing at every moment of the time. And as I mentioned, the continuous development, the gradual build-ups, the rollout of new versions and everything is one of the scenarios that we are doing that all the time, and our monitoring is covering it very well.
Yeah. Moreover, we are a AI provider. We provide AI analysis. We are based on AI software, and that's need to be monitored. And the monitoring of AI as monitoring of like many pipelines is complex, and moreover, the complexity resides in our case on the fact that we are providing live prediction, live detection. So our prediction have to be up to date. Whatever interruption in the pipeline or in the calculation will result in not up-to-date prediction. And we also have to make sure that the data that you consume, that we train on our models, that the data that we use to learn, they have to be reliable. They have to be, again, up-to-date and stable. And this is becoming more and more important matter, also because, and now we are hearing a lot talking about regulation of AI. And so monitoring will be a big part of being compliant with the legal requirements. For example, probably many of you have heard of the European AI Act that is going to be fully in place in a couple of years. And this will include a part on mandatory monitoring of AI for all those providers that provide AI services in a high risk sector. High risk will be whatever will impact everyday life, like healthcare, for example. So let's, before starting to talk about how we monitor, we have to talk about what we monitor. So let me introduce Eyer, what we do, what we are, and our algorithms and pipeline. First of all, Eyer is providing machine learning and anomaly detection for numerical time series data nowadays, and it's a solution that is exposed through APIs. So we are exposed to APIs both on the side of receiving the data and on the side of delivering the result after our analysis is done. This means that basically we can be integrated seamlessly into any pipeline. So you don't have, for example, to learn a brand new UI if you want to use Eyer. You can just pipe our result in the UI that you are used to. And later in this webinar, you will see some examples of how we build some dashboard in Grafana. But also this means that Eyer is a purely machine learning operation pipeline. So everything in Eyer is devoted to streaming data, delivering data, analysis, running algorithms, pre-processing, post-processing data. So it is a perfect example of monitoring of machine learning pipeline. And if you can go to the next slide, please. And let me talk about the algorithms. I'm the algorithm person in Eyer, so I will introduce what Eyer does. And Eyer mainly does 4 actions with the data that we get in. We have a part that is analyzing metric by metric, time series by time series, and building baselines that describe the behavior of each time series. And we don't build a single baseline for each time series, but we build multiple baselines, which means that we have a baseline, one main baseline that describes the most frequent behavior, that it's a behavior that we are pretty sure that is anomaly free. But this is not enough. We are also looking for secondary behaviors, secondary baselines. And these are behaviors that are less frequent. And since they're less frequent, it's more difficult to say that these are completely anomaly free. They might hide anomalies. Also because when we get in the data, these are not labeled. We don't know if the data that we learn from are actually completely anomaly free. Then, second step, you use this baseline to identify anomalies, deviation from this normal behavior. And we also assign some criticality to each anomaly because if we are in the main baseline, it's completely anomaly-free, your behavior. But if you're in the secondary baseline, yeah, even if this most probably is a completely normal behavior or already observed in the past anyway, that might add some anomalies, so there's a bit of criticality. The most critical behavior is if there's a substantial deviation from every baseline that was observed before. And this is, as I said, is a metric by metric analysis that we do, but then the metrics, the time series describe a bigger picture. So there are correlation among this time series, among all the resources that are in the system that we monitor. And so we scan automatically all the correlations in your system, and we update this daily. And at the end of the day, we pack together all the anomalies that happen on correlated, intercorrelated resources on time series, and we deliver a unique alert. And this is both to give context to the deviation and the anomalies that you see, because an anomaly is not an isolated thing. An anomaly can impact, an anomalous situation can impact multiple resources at the same time, and also to reduce the alert fatigue, because deviations on correlated resources are most probably part of the same anomalous event. So we alert just once for all these anomalies happening on correlated resources. Next slide, please. This is a bit more detailed view, and you see that this view is already rather complex on all the pipeline, but it's only from the algorithmical point of view. So from this slide is left out all the details about the pipeline, how things actually are running. Tigran will drive you through that a bit later. But only if you consider the algorithmic situation, you see quite a lot of complexity already. So we have the ingestion of the data. Then you see the upper branch in this graph. It's all the univariate analysis I was talking before. So univariate means metric by metric separately. Then the lower part of the pipeline is more the correlation part, in which we scan and all the time series to find mathematical correlations. And as you see, every branch, every step requires cleaning, preprocessing the data, preparing, and then at the end, we recombine everything into the alert, and then we have to send all this information and we expose them to APIs to do multiple things. So to receive the alerts, and pagers have like dashboards and build topologies, representation of all your system. So next slide, please. Now this is just a sneak peek on what you are going to see afterwards. These are screenshots taken from Grafana dashboard. These are just some possibilities of what you could possibly visualize with using the information that we expose. So on the top left image, you see like baselines of like a representation of like one metric with the baseline, primary, secondary baseline, and on the right image, there's a representation of the topology, all different resources and nodes with all the correlations and among them. And later we will have more demos, so you will see these things a bit better. And also, for example, you can use all the information you get to get like how many alerts there are, what is the portion of your system that is impacted. So how many nodes, how many metrics are impacted, what is the status of criticality. But now I give the ball to Tigran, so he can drive you through the pipeline, the architecture of the pipeline a bit.
Thank you. Now if you can go back to the presentation. And the next slide. So basically this is a bird's eye overview of our architecture without going into too many details. We are a cloud solution hosted in Azure. It's mostly Azure native, but we're using some AKS and what I call the hybrid services. So our solution is basically clustered into four main areas. We have the external ring of the APIs on the very left of the screen, and those are the APIs that are serving for the ingress of the data, as well as serving for the outgress of anomalies, metadata, correlations, and everything related to our discovery. APIs are, all the components are basically asynchronous. They're connected with message buses, and the data from the APIs, ingress from the APIs, goes into the data pipeline, which would apply the downsampling algorithm of a choice. It will apply the anomaly detection algorithms. It will do the anomaly reporting, the process that Alessandra was describing when we actually use the correlations to enhance the alerts that we're presenting to end users. And in the end of the day, everything is landing in data storages. We have a mixture of data storages based on a purpose. That data is as well landing in the machine learning tasks that are running on a schedule and that are performing the operations of baselining. That's a continuous operation that's happening all the time. They're also performing the operation of calculating correlations and also some other important artifacts that is used inside the anomaly detection. And that stream of data, whenever the machine learning tasks are running, is merged back into the data pipeline, so we can use the discoveries for further anomaly detection. And in the end of the day, all the data, all the discoveries like anomalies, alerts, correlations, etc., they land into the API for availability for external integrations or API usage. Can we go to the next slide, Ivar? So for ourselves, what we're doing, we've set up some number of data sources, and those are mostly segmented in three big groups. The first big group is native monitoring capabilities of the systems we're using. So it's Azure infrastructure, native monitoring. It's the data storage monitoring using for MongoDB, InfluxDB, and other data storages we're using. For all of those, we're using some open source data collectors that allow us to standardize the data, get into some JSON format and fit it into the Eyer. Eyer is agnostic to the format. We can receive any JSON, but it's always nice to massage the data and enhance it with whatever metadata is available from the infrastructure. Then we have a bit more specific route for the AKS monitoring, because out of the box Azure is providing almost nothing. So you have to do it a bit deeper. And the second big cluster is the business metrics. Those are the access log. There are some tenant-oriented metrics. It's machine learning executions metrics that Alessandra will present a bit later on, and as well as some custom metrics that we're emitting in application on demand. So something important for the investigation of application health and behavior. And then another thing we're building right now, it's not a final solution. And of course, all these things are not final. So we're in, it's an ever enhancing set of metrics that we want to monitor. There's never enough monitoring. But what we're trying to build now is also some business metrics that we collect from the artifacts. So we have the data in databases, we have all the artifacts coming from machine learning, and a lot of business metrics can be actually derived from that. And those metrics will be actually represent the health of the system from business perspective, as well as health of the system from technical perspective. So it's a very important track we're taking. Can we go forward? And then all the data that we collected is actually submitted to the Eyer. We let the Eyer do what it's supposed to do. It builds the normal behavior patterns. It builds the correlations. It analyzes the data that comes live in. And then per alert, we create it if there's an anomaly happening. We're gonna ship back the severity of the alert, as well as some internal machine learning statuses that allow us to basically weight the alert and validate the conditions. That data is fed into a visualization system of a choice. We're using Grafana, but we're not restricted to Grafana. Any sort of visualization system can be used here. And then upon some certain conditions, so for example, if the severity is this, or if the number of included subsystems is more than something, or if some specific subsystem is included, pager will be triggered. And this allows developers to actually react to stuff happening in the system and proactively prevent the anomalies to escalating into customer-facing incident. And one important thing that we're doing right now is actually trying to backfeed the data into the infrastructure providers and use the data from Eyer to customize the scaling rules we have. Because usually in the infrastructure, we have some standard scaling rules, scale based on this, scale based on that. But scaling based on anomalies from Eyer will be much more interesting because we are analyzing multiple metrics per subsystem. So it's not like if memory is high scale, it's if combination of metrics is outside of bound scale, for example. What's also very important, we're analyzing for the dependencies, the correlations. So if, let's say, we need to scale the database, then maybe we also need to scale the applications that are working with the database because the data amount is higher now. So those hints would allow us to do much smarter scaling than just, scale if the memory is high or scale if the ratio is too high. And I actually want to, if we switch to the Grafana dashboard, I want to present one of the investigations dashboard we're using. Here we have a representation of one of the alerts happening in the system. And actually, as we're sitting here talking, I was watching this alert escalating from yellow on some of the, every circle here is a subsystem within this alert. So from yellow, which means medium severity, probably something we observed in the past, it escalates to red, which means, react now. Thanks God this is not a production, so we can continue to sit here and chat. But basically here we see the subsystems, and we see subsystems that are included in an alert, as well as how they are correlated, and if there's anything external, like these gray ones, something that's correlated to the subsystem, but it's not actually inside the alert. And we can structure this data as we want, but it's always nice from our perspective to see what can be affected. Okay, these things are out of bounds now, but what can be affected later on. And then I'm going to just filter on one of the components and show some graphs here. So you see we have the per component there. It's different set of statistics based on what the component is, if it's a web app or service bus or virtual machine. Obviously, it's going to be different. But then we see some metrics. And for example, in this case, we see that the memory working set is right now outside of any corridors, which is the trigger for the anomaly. And previously it was running inside the secondary corridor, which was the yellow anomaly. And if we scroll way back in the past, it will be in the corridor, or kind of like this data in and out. Another useful thing we're using is the history of the alert, which will actually show how it's evolving in the time. So it started like, I don't know, some hours ago. And then it started with some nodes, some more data was added, some more subsystems affected, some more metrics affected, and then it gradually de-escalates and returns to the normal state. So this is a demo at a glance on how we're using Eyer to monitor infrastructure, and I hand over to Alessandra to talk about the.
I just want to. I can add one thing. Like if you go down in the graph here, it's you see it was here you see a lot of like this main and secondary baseline, and if everything was staying in the secondary baseline, this would have not been critical at all. It's those that are popping out of the secondary baseline that are driving the things up to be critical.
Yeah, it's funny, when we just started the streaming, all these nodes were yellow, Alessandra. They were within the secondary baselines, and you just see it escalating. Yeah.
Yeah, I will check immediately. But as Tigran said, this is like our test environment, so it happens that the things are going red sometimes. And yes, before we go to this part, I have a couple of slides, Ivar, if you don't mind. It's because now I want really to focus more on the AI monitoring part. So what does it mean to monitor an AI? This is actually a question that we had to ask ourselves too, because we are an AI provider and we will be under the AI Act. We will need to monitor ourselves. But what does it mean? What do we have to monitor? And so this is like some considerations that we have done and the steps that we are setting up for ensure that our AI is healthy and running well. So there are a lot of time series that we can monitor about the runs of every single algorithm and machine learning algorithm that we have. So how many runs happen and how many successful runs there are, how many failed runs, what is the average execution time, is there latency in there? But another thing that for me was extremely useful, actually, because I'm a data scientist, I just think about mathematics, I think about algorithms. It was not like my first nature to think about like the architecture, the pipeline where everything was running, and to have a tool to really discover the topology, discover how my algorithms correlate to different part of the pipeline, different resources, different function apps, storage accounts. It was extremely useful. And this is a type of information that I would not have without I would have always to nag Tigran to know what is going on, what is happening. If I see a delay in the execution of one of my algorithms, and like a delay in a result, the delay.
Did we lose Alessandra?
Yeah, I think. Let me double check. Oh yeah, and Alessandra is back.
Yeah, sorry, I had like a network problem, I think. Everything went dark. Yeah, if I see for example, if I see a delay in in the execution of one of my algorithms, in the delivery of the prediction of my algorithm, that could be a problem. Okay, I'm hitting like a limit or like a bottleneck of my algorithm, or might be that there's some delay in the pipeline. Like this, I have at a glance, I can just go in and see if there are problems in the related resources to that particular job, that particular algorithm running. And then other things that I can monitor over time is like the output. Monitoring, in the case of Eyer, monitoring how many baselines are produced, how many nodes get correlated every day. I could even choose some specific resources and monitor how the correlation over time evolve between these two resources. Let's make an example. I have in my pipeline, I have a storage count that I use to store the backups of all the baseline that are calculated every day. And then I have the function app that is delivering this baseline to the anomaly detection engine itself. So these are tightly correlated, because in the moment in which the new baseline is produced, is stored and sent. If this correlation disappear, that's a problem. So either we are not storing the backup, or we are not sending out new prediction. So this is something that I could get automatically alerted with Eyer. And moreover, Eyer also determine if like a corridor, a baseline is reliable, not is produced with enough data, with enough statistics. What typically happens is that when we connect Eyer to a new system and we start to collect data, in the beginning, it will say, okay, this is the baseline, this is the deviation that I see, these are the anomalies, but this is not really reliable because I've seen very few data of this type. I have not enough experience of your system. After a while that Eyer is watching and learning, everything should go, yes, this is reliable, and of course there are some data sources that are constant and more reliable, some data sources that naturally will have interruption, but after a while, if for a resource, for a time series, we say we have a reliable baseline, this should stay a reliable state. If this degrades to unreliable again, this is a situation that should be alerted, because this could be a degradation of the data coming in, a degradation of the data source. Data were coming in initially every minute, and then all of a sudden they come in every few hours. And at the same time, we want to monitor, again, for monitoring the reliability of the data that we use for the learning. We want to monitor like frequency at which the data come in, and also how often they change their value. So over time, this we expect to be more or less stable. So we want to be alerted for sudden changes in this. Also, and here we enter maybe the more experimental part, because there are still a lot of things that we want to learn about monitoring AI. We have sort of think like what we can monitor to see like how our algorithm and the performance of our algorithm is perceived. Okay, this is not bulletproof, but for example, we could monitor metrics that tell us how the user interact with our algorithm. So, for example, we could monitor like the number of requests to a certain API that we get, and so if this stays the same, increase, decrease over time, is all information that are that can be useful. And then we can build like more metrics out of the logs, for example, counting the logs, the templates, because now we are focusing a lot on numerical time series, but there are also log in IT system and ML system. Another thing is autocorrelation, for example. The autocorrelation are those that indicates you if there are cyclical behavior in your data. Next slide, please. Yeah, there was one more slide. And yeah, and this was specific to Eyer. Of course, when we talk about monitoring machine learning algorithms, every machine learning algorithm is on specific thing, but there are things that can be generically useful for whatever algorithm you are going to monitor. And the performance of the AI algorithm from the point of view like the runs, the latency, it will be something always applicable. And also like metrics from the pipeline, the performance of the pipeline, all the CPUs things, and are things that you want to keep an eye on always. The discovery of the topology, as I said, especially if you are not an architect, is fantastic. It's something that is super useful. And also monitoring correlation among critical resources is something that in view of also this tight interplay between algorithm, software, and the pipeline, the architecture. And then, I mean, some examples of like monitoring the user interaction, monitoring the average number of the average time, the number of requests, and the number of refining question that you have to ask to an LLM before the user is content. I don't know. Another thing that is important is, again, is an ML operation is also automation. When it's time to retrain your model, you can monitor metrics that when they start to change, they might indicate that it's time to retrain your model and trigger automatically the retraining of that model. I mean, here I wrote an example that could be, for example, if you have a classification algorithm and you get and you have like one field that is unclassified, then when that unclassified field grows too much, it's time to retrain. But since we don't have much time left, let's jump into the second demo. That is, yes, and this is another dashboard that actually, this is a dashboard that I am mainly using. This is a dashboard that I built. And the first element that you see on the top of the dashboard here is built using Grafana Canvas that allows you to combine like static information. Like in here, you might recognize, I don't know if Ivar, you managed to jump back to that slide with the the pipeline of the algorithmic pipeline in the beginning, you might recognize this pipeline here. So all the univariate block there, I just collapse into something that I call baseline, and the correlation pipeline block I collapse into something that is called correlation here. But what is this dashboard? It's basically my view on elements of the pipeline and architecture that otherwise I would have no control on. And so I build this canvas basically looking at the correlation. The topology here is like just a filter part of the topology is filter on just some resources that I'm particularly interested to keep under control. And I extract information from here, and I add here some metrics, and these are live metrics. So I can, like, at a glance just see if everything is running. These are live metrics coming from Eyer, so they are already pre-processed by us. And here is the service bus, the message bus that Tigran was talking before. I just always keep an eye that everything is fine there, that there are not gen messages there. But this is just like the last state, but I can go deeper and I can see at every.
So you basically started with the resources you know, and then worked it backwards using the correlations to include everything. Yeah.
Exactly.
Okay.
I started from what I know very well. That is the pipeline that I designed, the algorithmical one, and I went to the correlation view, our topology, and I populated like with some key resources, just to have like at a glance view. And also these key resources, I also down here, I started to plot all the history, like now it's the last 2 days. And also I want to show this because I was wow, like this when I saw this, it's a very good connection between pipeline and algorithms, because this is like a function app, the memory of a function app, that is the function app that is delivering. Let's see if I can plot the last 7 days. That is delivering the corridors, the freshly calculated baselines to the anomaly detection. And see, here we have like the real data of the memory. And if I add the main corridor here, we see that the main corridor actually it's really capturing this periodic peak that are the peak of the scheduled run of my algorithms. So this is, as I was saying, the main behavior is the most frequent behavior, and this is what is happening on a schedule every day. But also, you see here there are other peaks. But if I go and add the secondary baseline, we see that most of these peaks are secondary baseline. And you know what is this? These are the runs that I have been triggering manually, maybe because I was testing or because I was deploying something new. And they happen typically during my core working hours because I trigger them manually. And so it's the first half of the day. Then one night I was working late, and here is what happened. That was something that usually is not included in the secondary baselines, because usually that day of the week I don't work that late. But yes, it triggered an alert here. And this is fantastic to me to see how resources that I almost didn't know that they existed before are reacting to my algorithms. Yeah. This was basically what I wanted to show you.
Okay, Alessandra, thank you so much. I'm just trying to. We're actually now. Yeah, okay. So we're done.
Yes, we are done.
Okay. It doesn't look like we have any questions at the moment, so I guess it's time to conclude the session. Thank you, everyone, and look out for the recorded webinar to be published, and soon going to be published or invited to a new webinar just over New Year. So happy Christmas, everyone.
Thank you.
Thank you. Thank you, everyone.